So the next question will be gonna interesting more, which is known as majority of element. So this is the famous question asked by many product-based company. So please focus on this, guys. So here what they are saying is one array is given 8 comma 8 and 3 4 8. One array is given and they are saying the element is majority, the element 8 is majority. Why? And majority element definition here is n by 2. If any number is occurring more than n by 2, then return that element. So n by 2 means here what? N is 5 and 5 by 2 is what? 2. So 8 is occurring how many times? 1, 2, 3. So 8 is occurring 3 times. So 3 is greater than 2. Then return the element. So this is the definition of element. Is it looking interesting, guys? We need to find the element who is greater than n by 2, right?
Yeah.
Okay, so let's discuss the brute force approach for this. How we can say we need to find the count of the element. So it's the simple, right? We can find any count of element and we can update in our maximum or something like that. But let's discuss the brute force approach. So brute force approach says here, first thing we need to traverse through whole array. That is for sure. One thing is there. I will traverse through whole array. If I traverse through whole array, first thing I will initialize my current or count as 1. Means I will found the always element 1. One element should be always exist. That one thing is sure. And I will traverse through again from 1 to n. To check now, I will check if my array of I is equals array of j. If it is only equals, then update my count, otherwise don't update. If I found the element both are equal, then update the count, otherwise not update. And say if my count is greater than n by 2, then return array of I, right? Otherwise return -1. So this is the approach, brute force approach, guys. Is it clear?
Bro, I heard that.
Yeah.
If array is like 888, what will be the return?
888
333.
333.
Yes.
So 888 So both are majority, right? You are saying.
Yes.
So here the condition will be given, write any of the element. Okay, let's see that test case as well. We can, here majority element is there, not elements, I guess.
If 8 is also occurring 3 times, 3 is also occurring 3 times.
Right. So we can write any of the majority element, either 8 or either 3, right? Correct? You are getting my point?
Yes, yes.
So suppose 3 is there. Which one is majority now?
3.
3. So both are equal now, right? 3, 3, 3, 8.
Yes.
So write any of them.
Okay.
Get, right? So this is the brute force approach we discussed, like traverse through, keep one element, traverse through another element and find the element and update the element if it is exist. Right? So the time
I have understood.
Tell.
If in your array, if I add 6 and 7.
Okay. 6.
Don't remove that.
Achha,
Keep it.
3, 3, 3. Okay.
6, 7.
Ah.
Now the n by 2 value will be 4.
4. True.
Now the
4. N by 2 will be 4. Okay.
8 occurs only 3 times, no?
Right. So
Then,
3 is not greater than 3 is less than 4, right?
yes.
Then return minus 1.
Okay.
No element exists.
Okay.
Yeah. Another doubt, anything? Tarun?
No, bro, it's clear.
Okay. Time complexity, anyone?
N square.
N square.
Super. Space? It will be O of 1, okay? So now let's discuss the optimized approach. So optimized approach is little tricky. So optimized approach, what we are going to discuss is, it's known as Moore's voting algo. So this is also a famous algo, so that's why it is asked in many product based companies. So this algorithm is also easy, just a 3-step algo. So what it says is, find the number, then validate the number, and the step 3, return the number. So this is the Moore's voting algo says, just a 3-step. Find the number. How we can find the number? Means we need to find the number. Either I will keep one more 8 here for better thing. So we need to find now number. So we need to, maximum number is 8. We need to find the 8. How we can find the 8? So let's see. So one thing is sure, that I'm gonna run the traverse through whole array from 0 to n. I'm writing for this now, just a basic idea. And I'll say, finding a number, I can say if array of I equals if array of I equals number, or if my count equals 0, I'll say what count here is, and otherwise first I need to take I'm taking the number as, initializing the number as -1. No number is existing when we are not traversing the array, and I am taking the count 0, means initial count of the number is 0, and we will gonna traverse through whole loop. Okay, initial count will be 1. Why? Because the number will be always, initial count will be 1, and we will, let's traverse through whole array. So if we are traversing through whole array, I will gonna check if my count is 0. If my count, if okay, my number is 8, count is 0, then increment my count. So I'll say my count will be 0. I got pointer here 8, and count got increased as 1. Okay, my count is got increased 1, and I got the number as 8. So if I got the number, I will update it with else if array of I equals number, then update my number here as well. Okay, and increment the count and update the number equal to array of I. Else if when array where number equals increment the count, else decrease the count whenever number is not found. So here I am finding the number. Okay, so let's see how we are finding the number. I initialize the count as 0. No number count is there, and number is -1 initialized. So when I started with the 0, number 8, my count is 0. I increased my count, and number got array of I, which is 8. Now my number got 8. Now array of I is what? Again 8. So increase the count with 2. Again number 8, increase the count with 3. Again my number 8, increase the count with 4. So it got increased the count with the 4. Now I got 3. decrease the count. It got decreased. Again number 3, decrease. Again number 3, decrease. And again I got number 6, which is another number. So decrease it with 0. But my number is what? 8 only, right? So we need to validate now. We got find the number. Now validation of number. How we do the validation of number? So for validation of a number, Moore's algo says traverse through whole loop again and see if number exists or not. If array of I equals number, if it is there, then increase the count again and initialize before the loop as count equal to 0. Why count equal to 0? We are validating the number if it is getting increased or not. So whenever we find the number of as array of I, then we are incrementing the count. And if we incremented the count, then what? Last step, return the number. How you should return the number? If my count is greater than equals to n by 2, then return the number, otherwise return minus 1. Guys, did you got this? Let's code this out for our better understanding. We'll run. Okay, so let's code it out. I'm traversing through whole array and up to array size, and first thing I need to find the number. So to finding the number, I'm saying if my count is 0, then increase the count and update the number with array of I. Otherwise I am saying if my array of I equals number, then increment just count, else decrease the count. Here we are finding the number, so I'll say int my count 0 and number with minus 1. So you find the candidate here, find the number. Next step is validate the number. How you should validate the number? For int I equal to traverse the loop again and check for if array of I equals number, then increment the count, otherwise don't increment. Initialize the count here as 0 again. We are checking for the count again, and at last return the number. How should return the number? If my count is greater than n by 2, then return the num greater than equals to n by 2, otherwise return minus 1. So let's run this out and check. Okay, we should initialize n means a dot size. Okay, test case are passing. Let's submit this out as well. Okay, it got submitted as well. So any doubt guys so far how we are calculating in 3 step? Hello, any doubts guys?
No doubt, sir.
You got Moore's voting algorithm. We are finding the number, validating the number, if number is same or not, otherwise return the number.
Yeah, it's clear.